Welcome to the next section of our course, Advanced Automation Testing of Modern Application with C#.NET. And in this section, we'll be talking about UI testing. So we talked about the testing pyramid in our last section, where we have something like unit testing, integration testing, and UI testing. But we are going to start our first section as UI testing in this course. So we already know about our application architecture, where our application has an UI and it has an API and it has a database which is going to be responsible for getting the data for us. So that's how the application architecture is looking like. And the one which we are going to be testing in this particular section and a couple of more following sections is going to be the UI of the application, which is the one which is highlighted on the blue box there. Well, as that said, starting this section, we are going to be talking mostly on the UI testing. So let's talk about the UI testing a bit. UI testing. UI is the customer facing component of the application, and testing UI proves the whole application is working as expected, and we can cover the end-to-end logic on them from the UI itself. Because if you try logging in your application from the user interface and if logs in correctly, then you are almost testing the user interface, the API, and as well as the database or any Azure service bus or whatever, the connectivity, everything, if the application logs in. So you just perform entry of username and password in the UI and click the submit button. And if you successfully log into the application, which means it's proving a lot of wired up connection happening behind the scenes in your application, and you are also testing that you are successfully logging in to the application. That's great. So that's about the power of the UI testing itself, which is the whole thing about UI testing, kind of very, very popular. As the first place, most of the testers starts in many organizations. And UI test is becoming easy with modern tooling due to record and playback nature of the tools. For example, Selenium has got Selenium IDE, which you can use to record the test from the UI, from the browser, and that generates the code for you, or even you can run the test right from that IDE. And similarly, Cypress or Playwright, any other automation testing tool if you have heard about, all these tools also has a record and playback feature which you can use, which is great. That's about the UI testing, which is kind of very, very fairly straightforward and easy thing that you can think of. But on the flip side, the UI testing starts becoming very, very costly, as we saw in our earlier section about the testing pyramid, where the more you put or invest your time on UI testing, you end up spending a lot of money. So the UI testing is the costliest testing in the whole automation testing process. And the more we invest team and time in UI testing, the least the benefit we get out of it. So this is most important thing as well. We shouldn't be investing a lot of time for UI testing, because the more we start investing time on the UI testing, we start realizing that the application will start breaking up, and the test that we wrote for the UI testing will also start breaking up as well. And it is very, very hard to maintain, which we'll be discussing here on the flip side of it, which is why the UI testing is not recommended. The top 4 thing which I think of my mind most of the time. This is the one. UI testing is fragile, UI testing is slow, UI testing changes frequently, and UI needs to be tested in multiple browsers, operating systems, devices, etc. Because in my whole experience, every time I start doing UI testing, it always makes me realize that why is this testing starting to fail while it is working fine if I do it manually. And that's the reason about this automation fragility in UI testing. If your test is running good in your machine while you do it manually, and if it's not working in automation sometime, then it is fragile. And that's the problem with the UI testing. And also, UI testing starts becoming slow if you're going to be running on a remote machine, and if you wanted to run the test multiple times, then your test output is going to be quite slower. That's another problem. And because the UI of our application is going to keep changing each and every time, it is also very hard to maintain the automation testing code, and then we'll end up changing our code again and again, pretty much like how the application is being developed with a lot of features. So that's other problem. And also, because the UI testing needs to be done in multiple different browsers, operating systems, and devices, this becomes harder as well. So how do we actually make these UI tests more reliable? This is why this course is all about, right? So how are we really going to do that? Well, We could potentially use modern testing tools and libraries like Selenium, Playwright, or Cypress for that matter. But again, it is not guaranteed that they are always going to be reliable. This is most important thing we need to understand, because at the end of the day, even though this tool is going to help us automating the UI, it is an UI and it is fragile. That is the most important thing we need to remember. But we could use some techniques like lazy wait or fluent wait, automatic wait, which are available in many of the modern tools like Playwright or Cypress, which does for you. You don't really have to put some explicit wait or implicit wait for that matter. It does those for you. By having all these things, you could able to probably make your test reliable. And we could run or rerun all the tests if they are failing, which is another way that you could do it. It is available in some tools like Playwright. And also make application under test more testable, which makes testing more reliable. We need to first of all ensure that our application under test is more testable. The more the testable application is, the better the testing will be. And this can be done or achieved by us like a testers going to the developers, telling them that this ID doesn't exist or this component cannot be tested, make it more testable by giving or exposing some of the APIs which can be used by these automation testing tools like Selenium or Playwright for doing that for us. So that's other way to make this happen. And then how we can make our UI test fast? Well, we could run our test potentially in parallel test execution, somewhere like Selenium Grid or dynamic Selenium Grid. That's a possible way of doing it. And similarly, if you're going to be using tools like Playwright, we could run the test in parallel using the workers thread, which will also spawn multiple different browsers and run our test in parallel. Those things we could able to achieve it. That's quite simple. But this is the only way we could make our UI test run faster. We could run them in pipelines, but again, because they are going to be running in pipeline with Docker as a headless browser, there are chances that it might go slower. But we have a section completely covering how we could able to use Docker containers to run the tests in parallel using Selenium Docker Grid or dynamic Selenium Docker Grid in much detail in our upcoming section. Well, as I said, the next quest is how to handle the changing UI. Well, if your application's user interfaces keep changing each and every time, then don't automate the UI, which is frequently changing. Don't invest time in fragile UI, rather perform component testing in UI, which helps test things better and reliable. So this component testing is something which is already available in many automation testing tools. We could even potentially do that in an ASP.NET MVC application much easily using the web application factory, where you could able to test a specific UI component to see how the interactions are and things of that nature. We could do that so that you can ensure that a particular component of an UI is working as expected. So this way we don't have to rely on any browser versions or operating systems like that. We could able to test it in a component level rather the whole UI itself. So this is how we could handle the changing UI. And finally, how we can handle the multiple browser testing. Again, this is something we could able to do it using parallel execution and multiple browser to be passed as a parameter. We could do all sort of jazz and we can make this happen. So this is another way to do it. Well, we have seen all these slides right now, but how do we really achieve all these magical things that we are talking about? Well, we need to build a solid test code design for that. And we need to have a better understandability of our application under test, solid reusable components and framework which can be extended should be created by us, and using the best of the breed libraries available to make this happen. So this is very important, and this is what this whole course is all about. We are going to be writing a solid test code design so that we could able to extend the component or the framework that we are going to be writing for any kind of test that we are going to be writing in the user interface or API or whatever. And then we need to first of all understand the application. And that's the reason we have the application development as a part of this particular course, as a crash course, so that you could actually understand how to build an application from complete ground up, and then how to test it and attack it to see how you could potentially find some of the vulnerable issues within our application. So that's why you need to have a better understandability of the application under test. And finally, we are going to use some of the best of the breed libraries, which are going to be these libraries. We are going to be using Visual Studio 2022 with C Sharp 10 and .NET 6. So these are something released just a couple of weeks before while I'm recording this video. So this is quite new. And then we'll be using Selenium, XUnit or NUnit as the test framework, AutoFixture for mocking the data and getting an automatic data, and then Fluent Assertion for validation, pretty much like NUnit. And also you'll be using SpecFlow for the BDD or behavioral driven development, and also AutoFixture for dependency injections. And we can also use XUnit or dependency injection, which does that for us as well. So you may be wondering, why are we really worrying about the dependency injection here? Well, consider this. If you're going to have WebDriver object, and if you want to pass the WebDriver object across different class files for a specific test, or while running the test in parallel, we should handle that using dependency injection. And that's exactly what you'll be doing using this XUnit or dependency injections or AutoFac. We'll be discussing about those things in the upcoming videos of this course. But yes, these are the libraries that we are going to be talking about in this whole section and in this whole series. So with all the glories, let's start writing the Selenium code starting our next lecture.